Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about quantum mechanics, especially particle in a box, application of Schrodinger wave equation. So let us start learning with the historical background. Here you can see the historical E is equal to mc square. Now you can see the Bohr's atom, wave versus particle, and de Broglie hypothesis. Here, Heisenberg uncertainty principle, quantum tools like operator algebra and postulates, and Heisenberg. Then application, translational, vibrational, rotational, spectroscopy. So you can see the historical background starting from E is equal to mc square. Then h nu is equal to sc by lambda. Then you can see the SI is equal to SI. Then position and momentum greater than equal to h by 4 pi. Then Hamiltonian. Then psi functions. Psi n is equal to root over 2 by a sine n pi x by a. Then unity 0 to infinity psi square dx. Normalizations. Then nu is equal to HESC, and then energy n square h square 8ma square. Keep in all these formula in your mind when you are studying quantum mechanics. This is the genesis for the quantum chemistry and quantum mechanics. Now, genealogy of quantum mechanics. Classical mechanics, Newtonian, wave theory of light, Huygens, high velocity, relativity, low mass, quantum theory, and quantum theory related to quantum electrodynamics, and relativity also related to quantum electrodynamics. Now, wave theory of light, Maxwell electromagnetic theory, and this is coming from electricity and magnetism, Faraday's Ampere et al. So this picture and roadmap also keep in your mind. Now, energy and matter, size of matter, particle property, and wave property. This is also very important if you try to understand the quantum mechanics, and finally you have to learn about the quantum chemistry. Large macroscopic, mainly, and unobservable. Intermediate, electron, some. A small photon, few and mainly. This is the relations between mass and energy with velocity. E is equal to mc square. Now, the wave nature of light. You can see the visible 400 to 750 nanometer. This is the reason. C is equal to lambda nu and E is equal to h nu, the speed of light. So, you know about the gamma rays, you know about the X-rays, ultraviolet, infrared, microwave, and radio frequency. X-ray technique, you know, most of the Nobel Prize belongs to this range, X-rays. Microwave also very important. Radio frequency, NMR is working on this. Infrared IR working on this reasons. And EPR also working on microwave reasons. So, my friends, classical mechanics is based on the Newton's law of motion. Describe the dynamic proportion of the macroscopic world. It failed to describe the behavior of particles at atomic scale. The concept of quantum, the experiments of Young and Fresnel on light show that latter behave as waves. But with the Planck's quantum, Einstein photons, and Bohr's atom, it confirmed by 1920 that despite of wave-like properties of light, interference and diffraction, when it came to transfer of energy and momentum, light behaved like a particle. And this led to the concept of quantum, which means a bundle or unit of any form of physical energy, such as photon, which represent a discrete amount of electromagnetic radiation energy. So, in 1924, de Broglie made a formulation, and that particles behave like wave. So, you can see here, lambda is equal to h by p. You know this formula, where p is the momentum of the particle and lambda is the wavelength. All particles have a wave characteristic where they are moving with a moving momentum. The macroscopic objects which have a large mass have a wave with very small wavelength. So what is the conclusion? You know, my friends, the particle and wave aspect of electromagnetic radiation. The wave aspect of particles allows the calculation of the probability of locating the particle. The prediction of the locations of photons and subatomic particles like electron, neutron, etc. probabilistics, and the probability is given by the energy RT square. So, what is the need? The need of new mechanics for subatomic particles. This is very important line. The need of new mechanics for subatomic particles. Just keep in mind, the concept of continuous energy, absorption, classical mechanics, and emission was in conflict with the atomic and subatomic phenomenon, black body radiation, photoelectric effect, Compton effect, diffraction of electron, and atomic spectra of hydrogen. The explanation need to lead to the new mechanics called quantum mechanics. Very important point I am here discussing. You just keep in mind this important thing. The explanation lead to the new mechanics called quantum mechanics. Now Schrodinger equation, characteristic of psi. Psi should be single valued. What is the meaning of single value? Mathematics students know very well. Single means single value. Should be continuous and should finish for a bound state. Now application of Schrodinger equation, particle in a box, hydrogen atom, a rigid rotator, simple harmonic oscillator. Why these three? Hydrogen atom, because when we are talking about quantum mechanics and quantum chemistry, hydrogen atom, because of electrons and proton, rigid rotator. Why rigid rotator? And simple harmonic oscillators. This is very important to recall these three important terminology. So first you learn particle in a box, interpretations, plots of wave functions. This is the wave function formula. Here you can see what is the physical significance of n, significance of pi, and significance of x, and what is the meaning of a here. Plot of a square of functions. Then check normalization. Normalization means psi squared dot dx is equal to 1. How fast is the particle moving? Comparison of macro to macroscopic particle. And calculate V minimum of electron in a 20 angstrom box and calculate V minimum of a 1 gram mass in a 1 centimeter box. So you will get this energy formula. Now particle in a box, you can see reasons -1, here reason -3. This minus reason 1 minus 3 is nothing. This is not minus, this is hyphen. So 1 reason, 2 reason, and 3 reasons. So you can see V is equal to alpha, V is equal to 0 inside, and V is equal to alpha. So X is equal to 0, X is equal to A. So free particles potential energy is same everywhere, that is V is equal to 0 for free particles. Now potential box, potential energy is V0 within the closed region and infinite everywhere else. So this is the boundary condition. Now Schrodinger equations, you can see this is equation 1 for one-dimensional box. This is the equation 2, and region 2 and potential energy is 0. Then you will get the k square is equal to 8 by me h square, equation 5. Now solution of equation. So psi a cos kx plus b sin kx. Then reason 1 and reason 2, psi is equal to 0, v is equal to alpha. At x is equal to 0, psi is equal to 0 from, and then this is the second, 0 is equal to a cos 0, b sin 0, a is equal to 0. Now 8 and in 6, now you can see sin k is equal to 0, k is equal to nx, k is equal to n pi by a. So 0, 1, 1, 3 allowed solution, 1, 2, 3 acceptable solution. Now you can see n is equal to 1 to 3. Wave function for a particle in a box is equal to n square h square at m a square. This is the equation 10. Here you know the meaning of m, you know the meaning of a. E depends on quantum number which can have integral value. The energy level of the particle in a box are quantized. So normalization of psi. How you will normalize? This is the mathematical functions. So you can use the mathematical tools and then you come to the normalization point. The solution Schrodinger equation for a particle in a one-dimensional box is equal to, this is the solution, and energy is, so you have two parameters here, psi and energy. Now particles will have certain discrete values of energy. So discrete energy level means the energy of a particle is quantized, and this value E depends upon n, which are independent of x. These are called eigenvalue. So a free particle can have all values of energy, but when it is confined within a certain range of space, the energy value become quantized. So E1 is equal to h square 8ma square, E2 is equal to 4h square 8ma square. Why? When you have the n is equal to 1 and n is equal to, they have different energy. So E minimum is equal to h square at m square, lowest energy. So what is the 0 point energy? JPE. When the particle is present in the potential box, the energy of lowest level n is equal to 1 is called zero potential energy. So eigenfunctions, you can see n is equal to 1, psi value this, n is equal to 2 and n is equal to 3. You have the psi 1 value, psi 2 value and psi 3 value. So nodes, that is also very important. The point where probability of finding the particle is 0 in the particle wave. So n minus 1 nodes. Now you can see in this picture nodes. Where is the nodes? So in first there is no nodes. In first, second, n is equal to 2 and n is equal to 3. So greater the number of nodes, more the curvature in the particle wave. For a potential box of fixed size, as the curvature in the wave function increases, the number of nodes increases, the wavelength decreases, and the total energy in the box, potential energy, has been assumed to be 0. So you can see wave functions and probability functions. You can see the boundary condition in x direction 0 to L. So n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Now you count nodes. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.